Now we're going to look at an example where a complex alkane is attached to the main chain of the molecule. That's to say, not a simple pattern such as a zigzag shape described as normal, nor does it fall under the patterns of iso, sec, tert, or neo. So we need to name it as if it is a separate molecule. We're still going to start with the same old way by looking at the longest parent sequence of carbons, and that here is 9 carbons long. So we describe it as non-ane. Next, we need to number the positions at which the functional groups are attached to the main chain. We can go from left to right or from right to left. From left to right, the positions are 2, 5, 6, and 8. And right to left, where the positions are 2, 4, 5, and 8. Okay, so what's the lowest number? Well, both have 2 for the lowest number. So we have to look to the next lowest number, and that is either 4 or 5. 4 is lower than 5, so 4 wins, and we're numbering from right to left. Next, we're going to name the substituents and put them in alphabetical order. We're treating the complex alkane as if it were its own molecule. We're starting at the carbon that is attached to the main chain, and from there we're looking for the longest sequence of carbons. For this molecule, that is 3, so it's as if it were a propane. Now we need to describe the substituents attached to it. We have a 2-carbon unit attached to the 3-carbon unit, so that is ethyl. It's attached by the same carbon that is attached to the main chain, so that carbon is given the number 1. So what we have here is 1-ethyl propane, normally thought of as pentane. But because it's a substituent of a larger molecule, it will be described as 1-ethyl propyl and placed within brackets within the larger molecule name. Okay, let's look at all the substituents within the molecule now. We have 2-fluoro, 4-methyl, 5 1-ethyl propyl, and 8-bromo. Now we need to put them in alphabetical order. So we are looking at 8-bromo, 5 1-ethyl propyl, 2-fluoro, 4-methyl, nonane.